Howdy folks, Tom Barbalet here once again. Based on the overwhelmingly positive response of the last video, I wanted to record a little bit more of my Noble Ape development. So, when you create a new landscape, let's just look at this one. The most time-consuming part is actually the rounding. It's put together by, so if we search for land in it. This is the source code. So the most time-consuming parts are creating the patch, which is the fractal map, and then rounding. And the previous round function, which is still in the code, is this round function here. And what this round function does is it just, let me stop the simulation so I don't get the fan going. It, for every point, it goes plus or minus 1 in 9 points surrounding the central point. So, well, 8 surrounding plus the 1 central point. And adds all those together and then divides by 9. And this is very time consuming. This is done, I think, 7 times. This is done, yeah, 7 times in refining, and I think the round is done itself 4 times. Again, this one, so 6 times. So you've got 6 iterations of this kind of almost Gaussian-like blur, basically, that's rounding down 3 by 3 squares to a single value. There are 2 parts that I thought about this in terms of optimization. The first is that what you're dealing with in terms of scanning is actually adding and removing 3 points. So rather than doing math where you're adding and removing 9 points each time, you have a standard 3 by 3 which you define initially, and then as you move progressively you subtract this part which you're moving out of, and then you add the part which you're moving into, and that gives just a subtraction addition of 6 points, which is less than 9 points. So that in and of itself is okay, but we have now multiple processors, and what I've done with Noble Ape is I've added the ability to farm these kind of operations out to multiple processors. So I've recorded a previous YouTube about this, but this just takes, and I use it in a few places. I use it in the drawing for doing individual scans, but the main thing that I use it for is in the being execution. In fact, I don't use it here. I use something like it. Actually, I have a slightly more complicated execute add, which takes groups of information, and I think that's because what I'm looking for there is actually blocks of execution groups. So that's what the group does, which has a different version of add, but it's basically the same kind of thing. Anyway, so by doing these 2 things, by doing the, add 3, subtract 3, is the entry part, plus breaking down each individual scan, and I think I optimized for Y scanning, so the plus and the minuses are on the X's, or where are we? This is not even the right area, this is the right area. The plus and the minuses on the X's are, so you're really just taking 3 adjacent blocks of memory together, and then so it's smaller amounts. The other thing that I've added is this notion of a memory function which maps the X and the Y coordinates onto a block of memory. Historically, let's have a look how this is actually being used. Historically, this is the way it's maintained as well. So here, actually within round smarter scan, you have, I think, the memory function being defined, or the memory functions defined in here. Memory function, which is round smarter, and from this, math memory location, which is the old means of just working out where the memory is, which is, it exists in this case, I think it's an 8 by 8, so, sorry, not an 8 by 8, 256 by 256, this is a bit shift area. However, when I move to the dynamic land, there is potential for the edges to actually have an overlap of maybe 2 cells, maybe 5 cells, which enables for things like weather to be calculated and propagated through, but also for the rounding to be done correctly. So in those cases, I will use a different memory math function in order to map to the different sizes of memory that I'll be using for the dynamic scaling. Anyway, so that's a relatively dry piece that I've been adding, but the more colourful piece is that I've actually decided to on the format, on the underlying format, and the format will be based on the 256 by 256 grid. And if we do the math on this, it's what, 256 by, so it's basically 1,000 kilometers by 1,000 kilometers, which is a small fraction of the Earth. I think the final quote was, anyway, it's a small fraction of the Earth, but it's still a huge simulation area. And the purpose of having such a huge simulation area is really just to show that the mathematics is computationally possible. It's to show that it is possible to simulate a substantial area down to the resolution of, a creature, a humanoid-sized creature, basically. Maybe the insects around the humanoid-sized creature, but of that scope. And I think with distributed processing, all this kind of stuff, it's all good. Anyway, returning to what I was saying, so what will happen is, as it is currently, these maps are generated based on a average point, which is 128, which is halfway through the byte. And what will happen is that each of these points, it's always difficult because so each of these points will become the value that is put in there. So let's assume here it's at about 60. So let's have a look at what the map at 60 will look like. Now obviously this is going to be with the random generator, but let's have a look at the 61. Now of course this is going to be like drowning Noble Ape season. I think 60 was actually too low when I looked at the math, that I probably won't be allowing within 60, but it'll just give an indication. So this you can't really see, but this is what a 60, like, it's very deep water basically, and there's absolutely no land. It's just deep water and kind of ridges and shelves and what have you. So I don't think I'll probably be doing that low. I think I was looking at probably 65 as being the lowest that I'd do. Again here generating, but you can see here the speed of the actual rendering as well. So this is a pretty old crappy computer. So yeah, this will still give you some islands, but still very deep water. In fact, these are probably not even islands. Given time, they probably flood, so it's not really ideal for Noble Apes to be in these areas. And in contrast, the other end will be this end, probably. Yeah, it'll probably be 7 bits worth of land. Hard to tell, but it'll be in that area. And this is the other end of that, which is all snow covered, or almost all snow covered. But interestingly, actually, in this, with this generator, there's still water. So you'll still have interesting areas, even with these high generator numbers. You'll still get, good deep water and nice interacting levels, even though the land is that much higher. It's worth testing, actually going much higher and just seeing what that's like. kind of hesitant to go much higher than that. But let's see what this looks like. This is basically, should be almost all snow-covered peaks. And it might actually be a good motivation, yeah. It might actually be a good motivation for, yeah, so this is all snow-covered peaks. And yeah, it'd be interesting, so be interesting to see what the Noble Apes are like in these areas too. So probably more realistically, we will have, this will be the extreme. Let's see what the water looks like in the extreme case. And I'll probably just use the map as a generator, so I won't express any limitations. I'll just take the map value as the generator value. Again, yeah, so this is deep oceans, basically. Yeah, lots of beautifully deep ocean. So, recapping this again, what will happen is we will have a standard generator, and this will be at the super tile, let's call it that, super tile level. And from the super tile level, we will take each of these individual points and then use that as the basis, and obviously there'll be underlying random values as well that are used to actually define these points. But each of these points will then be their own tile. So this is actually in double resolution, but it'll be one of the 256 by 256 will be its own tile. And that will produce, I think, so I mean here you'll have the deep ocean characteristics here you'll have the deep ocean characteristics, and actually you can see you get the full diversity of landscapes. So, you know, here will be snow-covered mountains, but obviously each of these points, or at least points on the map, will be a tile. So it'll be this resolution again, but just with that point being the height and the generator underneath it. So you get substantially more landscape, and this kind of begs the question, what happens to the Noble Ape populations? Well, obviously substantially more Noble Apes and substantially more interaction, but also this idea of a kind of subset Noble Ape group, which is a majority of the population, as kind of non-player characters initially, non-fully sentient participants that will just be a kind of backdrop with maybe per tile, maybe 2 or 3. One thing I wanted to show actually, which is kind of difficult to show in this circumstance, but I'll run it anyway. Actually, it's probably better just to turn the brain off and just let them kind of forage. So let me just do this. I was having some correspondence with Heronstone associated with the territories. Probably the best way to actually do this is to run this from debug, which is always fun. And show it from the command line. So you can actually run Noble Ape from the command line and get the combination of GUI and command line. And this is actually the fastest way to run the simulation. And I turn the brain off too. Wow, gosh. And you get like lots and lots of apes. And this actually, the more processors, this machine I think only has 2 processors, maybe 4 at most. So it's not really giving us the full goodness in terms of processing. you are getting a bit of the strobing, so just turn that stuff off. Let it run as much as possible. So this is utilizing... It's actually considerably faster in non-debug mode, obviously. What you can do is you can turn on the territories, and actually in the small view it's not particularly interesting because there are only, 16 territories. But in the larger view there are 32 by 32 territories. And what this is doing is actually counting the selected ape, which is here. Well, we just lost the selected ape. But the selected ape, so you can select any ape actually. Let's select this guy. And you can see the territories. That guy just died. Actually, there's a bug in the selection code associated with death too. So if apes are dying through the selection. Anyway, so what you're seeing here is this ape, the count in terms of the number of, I think, seconds, number of minutes of daylight that this ape has been in the particular sphere. So this isn't particularly interesting at this resolution, but if you switch this up, to a higher resolution, I don't think, have I tested the threaded... Oh well, this will be a test, ladies and gentlemen. This is where the simulation crashes. I probably shouldn't run it like this either, so I'm just going to run it from the command line. So it's not that the simulation has failed, it's just that it's taking forever to actually start up. Here we go. And this is a crash. Because I hadn't actually tested out this new version with the larger memory. Very good. Well, this always tends to happen. Anyway, I'm going to cut the video short. No more cameras. I'm going to work out what's actually going wrong here with the larger land size. Anyway, Tom Noble Ape in the Bay Area. I'm going to be recording more of these videos as I work through basically what's going on. And just provide more information. But basically, you can see through the territories where the ape has gone, and the apes tend to be very confined in the kind of territorial areas. Anyway, Tom Noble Ape, signing out.